All right, in today's video, we're going to start talking about control structures. And so the primary structure is what a control structure is if you think about your normal higher level language program, it's your if statements and your while loops. It's the things that you build or write into your program in order to control the flow, the execution of that program. We're going to look primarily today at doing comparisons and jumps, which allow us to essentially create conditions. So think of those kind of like an if statement. And then we'll also take a look at looping. So here is a control structure. It's what makes our high-level languages Turing complete, and it gives us the ability to create conditional statements, so we can have branching logic within the program itself. Our primary instruction that we'll use in order to do that is then the compare. And so CMP, that's the mnemonic, and we compare register 1 to register 2 or an immediate. And so we have two operands, register 1, so this first operand here needs to be a register, and the second one then needs to be either a register or an immediate value. Remember, immediate value could be something that we essentially hard code 10 or A in hex or 1 or 2 or whatever. What happens then when we do the compare instruction is that it does subtraction. So it takes register 1 and it subtracts from it register 2. And then based off of the results, it actually sets flags. So we started looking or talking a little bit more about the flags register in the last video. Comparison then sets flags according to the results of that comparison and according to the results of taking register 1 and subtracting from it register 2. It's important to note that the result is not stored anywhere. So while it does a subtraction and it sets the bits in our flag register, it does not actually store the results anywhere. If you need the result of the subtraction, then you need to actually use the subtraction, the sub instruction. Okay, so what flags get set? Well, we'll have three flags that we'll be looking at: carry flag, overflow flag, and the zero flag. And so we'll take a look at those here just in the next slide. Remember that one arg, okay, so the first one is a register, the second one can be a register or an immediate value. All right, so how do we set the registers? Well, it's set for us by the instruction if reg1 is equal to reg2. So what does that mean? That means that if register 1 minus register 2 is equal to 0, then we set the zero flag. Okay, so register 1 minus register 2. If we subtract the 2, we get a 0, so they are equal, so the zero flag is set. If register 1 is greater than register 2, right, we don't set the 0 and we don't set the carry, because register 1 is greater than register 2. So we're not trying to subtract a larger number from a smaller. If reg1 is less than reg2, then we do set the carry, because if this register 2 is greater than register 1, then we would have to borrow in order to do the subtraction. So the carry flag is set because a borrow occurred. Right, so we have those flags being set depending on that operation. So we can take a look at an example here. You can see in the program that I'm going to move. Let's start with a simple example. I'm going to move into EAX 10 hex, and then we're going to compare EAX to 10 hex. Right, and so we're comparing the register to an immediate, and then after we do that, we'll dump the registers. So what we're looking for then is what flags are set in the actual eFlags register. Okay, so what would we expect? Well, they're the same value, so we would expect reg1 to be equal to reg2, so the subtraction would result in a 0. That means the 0 flag would be set, and you can see something's not quite right here. Okay, so you can see that what we're going to do here is we're going to move 10 hex into EAX, and then we're going to compare 10 hex to EAX. So we're going to take V left, or reg1, and subtract this V right, or reg2. This is an immediate value in this particular example. They're the same, and so what we're going to have is this case right here, reg1 equals reg2. That would be a 0, so the 0 flag should be set. All right, we can run this example now, and we can see that this area is where we're showing, is where this particular function shows the eFlags register, and it does it in a nice format for us. And that when a certain bit is set, instead of just showing ones and zeros here, it actually shows us what that bit represents. So we can see that the 0 flag is set. Now, if we change the value, I'll say that we make that value 9, so we're comparing 10 to 9. So reg 1 will be greater than reg 2. We should see that the 0 flag and the carry flag are both not set. And so we'll go ahead and I'll save that file. I'll run the program again. And we can see that they're not set. The fact that they're not printed here for this particular output means that they are not set. Okay, and now we can just take that same example and let's just swap around those values. Okay, now we have this case where reg 1 was less than reg 2. 0 flag is set because the result was not 0, and also the carry flag was set because it would have resulted in a borrow. And we can see that here. Carry flag is now set. Okay, so that's how we can use the comparison with registers with immediate values in order to set the flags that allows us to compare. The next thing that we need to do then from that is the jump. We need to be able to jump. So we do a comparison, and the jump is what allows us then, or allows the program to jump to another location to start executing instructions. Two types of jumps, the conditional and the unconditional. Conditional is what you'll see in conjunction with a comparison. So when we do a conditional jump is going to look at the flags and it's going to jump based off of how those flags are set. This is what this table is right here, simple conditional branches. Jump if, JZ, jump if the 0 flag is set. JNZ, jump if it's not set, if it's unset. Right? And so we have all these different conditional jump commands. Jump if 0 flag, jump if not 0, jump if overflow, jump if not overflow, jump if sign, jump if not sign, jump if carry, jump if not carry, and jump if parity, jump if not parity. Okay, so what will happen then is you'll oftentimes do is a comparison and then a conditional jump, because you're comparing values, you're comparing registers, and then you're looking at the flags that were set accordingly in order to determine how to branch your logic in your program. The unconditional jump then does not look for any sort of condition. The unconditional jump just jumps to somewhere within your program. All right, so let's go through and do a simple example. And the example that we'll do will be very similar to this in this C program. So if this is a C program, we're going to read a numeric value from the user, and then we're going to compare. If it's equal to 10, we'll go ahead and we'll print off equal. If it's greater than 10, we'll print off greater. And then if it's less than 10, we'll print off less than. And so we're going to try to essentially convert the same program logic into our assembly program. In order to do that, we need to declare a couple of variables for ourselves. So I'm going to say S1, which will be string 2, and we'll define bytes. And I just will say this first one will be equal. Then I will print off a new line, and then we'll have our null byte. We'll do the same thing. I'll do the same thing for string 2. This one will be for greater. Print off a new line, and then a null byte. And then also for string 3, which will be for our less than. Okay, let's see. So the first things that we'll do is we'll go ahead and we'll call readInt. Okay, and we know that readInt will read value into our EAX register. Okay, from there, then the first comparison that we'll do is we'll compare to 10. So we'll compare EAX to 10, to A. That would be 10, right? Okay. And now what are we looking for? Okay, if it's equal, we can go back and look at this table here. We're looking for the 0 flag. So between the 0 flag and the jump if 0, that's the condition that we're looking for. So we do the comparison, and then we can say jump if 0 to equal. All right, so what is equal? In order to get this example to work, we have to additionally define what is considered what's called a label. And so you can see that we already have this ASM main as a label. It's a name, essentially a named location. And so we give it a name, we use some alphabetic characters here, and then a colon. And that gives us a location in our program that we can now jump to. So I can create equal, right? Equals our label, and then inside of that label, so if we jump to that label, then we'll start executing instructions there. I can move into EAX, S1, and then I can call print string. Okay. So if everything works, then what we'll have is we can run a program, make sure I'll input a value 10, and we should see that it prints off the string equals. And there it goes. So looks like we're good to go. I'm going to get rid of this dump registers as well. Okay, well, what's the next condition? So if it's not equals, then I'm going to test for it being greater than. So what can we do then? Well, we can just do another comparison. Right? We've already done the comparison, so the next thing we would need to do then is the next jump. So if it's greater than, right? So we're comparing the value in EAX, that's the value from the user. So if it's greater than register 2, which is our 10, so whatever the user typed in to the value 10, we're looking for the 0 flag being unset and the carry flag to be unset as well. So the instruction, the jump command that we can use is JNC. We can say jump if not carry. From there, we can create another label called greater. And very similar, we'll move into EAX, S2, and then we'll call print string. All right, so let's see what happens. All right, we put in 10, we get equal and greater. Right, so our first test already failed. So what happened? Well, in our program right now, we said that if the 0 flag is set, so in this example, 10 and 10, that would set our 0 flag, we jump to equal. So we jumped to this label equal, and we started executing instructions. We moved into EAXS1, and then we called print string. When we were done, what happened? Well, we just continued to execute statements. And so what we oftentimes need is another label. I'm going to call this label done, so that once we're done with a particular branch, we can jump to that label. Right? Jump, and this is unconditional now. So we're saying you don't have to worry about any flags, you don't have to check any flags, you just simply do a jump. So now we jump to done. So once this code executes, we'll print the string and we'll jump to done. Right? Done is a label. It's just identifying a location in our program. And so this is just the end of our program. It's the end of main. And so we don't need any additional function or logic in here right now. So now we run this program. I'll put in a value of 10. And you can see that it worked. There's equal. Run it again. Let's put in a value 11, and it printed off greater. Okay, last thing that we need to test for then is when it's less than. And so how do we test for less than? Well, we're looking for the carry flag. So what we can do there, jump if carry, and we can just call that less. So here's our label for less. We'll move into EAX S3, and we'll call print string. Okay, now we have the same problem with our branch and greater. Once we're done, we need to jump to done. And we don't necessarily have that problem with less, because now that this is the last instruction, a jump to done would be the same thing. So we don't really need that there. Although if it helps just to keep the logic clear, you can go ahead and put it there. Okay, so now we can run a program, test it again. There's equal, there's greater, and there's less than. So it looks like we've got everything working just fine. Okay, what else could you do with this? Do you need to do a comparison, or could you just say jump to less? All right, something to consider. So let's make that change, and let's see what happens. Less than. Okay, that worked out. Good. 10 is equal, and greater than is greater than as well. Right, so we don't necessarily in this case, because this is the last case, this is essentially creating or testing for the less branch. If it's not equal and it's not greater, we only have one choice left. And so we could just jump directly to that, unconditionally jump directly to that location. Okay, so it's up to you. It's up to you to determine the logic. As you can see, there's a couple of different instructions that will allow us to get to the location, that allow us to get this flow that we want. It's much different than looking at an if statement in a higher level language, C, C++, C#, Java, whatever you're comfortable or used to programming in. It's a little bit different. We have to think about the comparisons and the logic and the jumping a little bit differently. And so take some time and definitely look over this code, especially I'll upload this source example as well. And just make sure that you understand how we're using the comparison in conjunction with the conditional jumps and then even the unconditional jumps in order to create a similar structure. When you start looking at assembly then, in one of the next labs, that's what you're going to look at. You're going to look at an assembly program that I give you, and then you're going to rebuild the source in C. You're going to see a lot of this, comparisons followed by a conditional jump. And when you're looking at there, that should be kind of your indication or your clue that you're probably looking at some sort of an if statement type functionality. All right, here's another example, and I'll just leave this one in here as an exercise for you to work through. Again, the quizzes are going to reinforce a lot of this, and so just making sure that you understand what's going on. Here's another example of looking at essentially an if skeleton, and so you need to create some sort of a conditional logic in your program. Well, this is typically how you do it. You have a comparison, and then you have a JZ, a jump if zero flag. Remember, JZ is jump if zero flag is set. You jump to a label. So we have label A, and then our end label. And so we do a comparison, and what this comparison is doing is it's saying, okay, if left is left minus right is 0, jump if zero flag is set. That means they're equal. So we jump to label A. So you can see here's our label, and then simply a comment in here that says this is the code if register 1 is equal to register 2. If that's not the case, then we don't need to jump, right? Because if it's not equal, then if it's equal, we jump here. If it's not equal, then this is the code to handle when it's not equal. And so we don't need to jump. We simply execute the instructions that we need for when they're not equal, and then we jump to the end label, because we run into a similar problem as we did in the last example, that if we didn't jump here, then we would drop into this code and we'd start executing here. All right, we're creating conditionals because we want either this to happen or we want this to happen. And so once this particular branch is done, we need to jump over this particular branch. Okay, so those are our if statements. That's an if skeleton, and here is a sample program. The next thing that we'll look at now is Loopy. And so we can implement for-like loops. We can also implement while-like loops in our code. Again, it's not going to look quite the same when we implement them in assembly as they do inside of our higher level languages. But the example or the structure, the purpose that we get out of them is pretty much identical. We'll have an additional command called the loop command, and so we'll say loop to the label. Every time we execute this instruction, then it automatically decrements the value in ECX and then jumps to that label, as long as ECX is not equal to 0. If ECX is equal to 0, then we don't jump to the label, to the top label, we just go past the loop. And so I'll show you an example here of that. There are some other loop instructions, Loopy or Loop Z, so it jumps if ECX is not equal to 0 and the 0 flag is set. There's Loop NE or Loop NZ, jumps if ECX is not equal to 0 and the 0 flag is not set or unset. But I don't see myself using these. I don't end up using these very often, as well as in all the disassembly I've looked at. I don't see those instructions very often. Usually it's the loop command, if anything. Okay, so let's create another example here, and I'll try to use labels that make it clear to what the code is doing. So I'll call this loop. Let's just call this top, and then we'll have our loop to top. Okay. So what do we do before that? Well, we need to set up our registers, right? If ECX is the register that we're using to decrement, then we need to move into ECX whatever value we want to decrement. So let's say that I want to use 10 or A in hex, right? Same thing, 10 in decimal. So we move into ECX, value 10, and now we enter what essentially becomes our loop, because we're going to loop to the label. Top is our label, so now once we start executing instructions here, we're going to continue to loop to the top as long as ECX is greater than 0. So in this case, I'll move into EAX ECX, and then I'll call print int, and we'll also call print new line, just to make it a little bit easier to see. All right, and then loop decrements ECX, and then jumps to the label. So decrements, tests, and then jumps to the label. So if everything's set up correctly, what we should see is a loop that prints off all the values essentially of our counter. Okay. All right, I guess I lost my connection again. Let's see here. Okay, I'll just go ahead and kill that terminal. Bear with me for one moment here. I get things reset. And let's see, 14. Okay, almost there. Okay, so we got to type in the value, 9, there we go, less than, and then there's our loop, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Because remember, the condition is looking for ECX to be not equal to 0. So as soon as that ECX register was equal to 0, then we no longer looped. And we did not jump to that label, so our execution continued, which was the end of our program. Right? We could have print off a string as well if we wanted to. So let's say I defined another string, define a byte, and we'll just print off X. I'll add a new line as well as a 0. And just as a refresher, or in case I missed it, what we're doing with this location is much like we're defining a label that's pointing to a location in our program. These are essentially labels or variables that point to location in memory for the address space. Remember, we talked a little bit about virtual memory. So the way that the program is loaded into memory when it's executed, we have space in memory for variables. And so this is essentially pointing to, just like a variable, right? It's pointing to that location in memory in order to find the data that we stored there. We have the data directives, so byte, word, double word. And so what we're doing is we're defining a byte because we're holding one character, ASCII character. ASCII character is a byte. So we're going to store one byte. This is going to define another byte. So it's not like we're trying to fit all of these characters into a byte. Each one is going to consume a byte. So X will be a byte, new line will be a byte, and then the null character will be a byte. Right? We can't put, for a new line, we can't just put /n because that wouldn't store that as that actual character. It would get stored as 2 individual bytes, one for the /, one for the n, and so it would fail to give us an actual new line. So we need to store the A, which is 10, which is the ASCII character, just numeric value for the new line, and then the null byte. And we talked a little bit about what happens if we're not careful about moving data around. If we forget the null byte, then when we go print string will just continue to read until it finds a null byte, which who knows where that's going to be in the program. It could cause it to crash. Okay, so we define that byte X, new line 0, and if we wanted to print something off in here, we could do that as well. Let's see, so we'll print our int, print the new line. Let's move into EAX S4, and then we'll call print string. All right, I'll save our program, and we'll run it again. And there we go. So now we just simply printed off a string value with each iteration. Okay, that does nothing. I mean, that really doesn't have any benefit to the program. But just as an example here to talk a little bit more about labels, how we use them, and then using them inside of this loop. Okay, the important thing is here though is that we're understanding how to do loops, how to use the instructions, the jumping, how do we make our programs branch conditionally, conditionally and unconditionally, and converting things like if statements into our program. Okay, there's another good example here. So if you look from an excerpt from the book, here's an example of a for loop. So sum equals 0, for I equals 10, I is greater than 0, I minus minus, sum plus equals I. This could be translated into assembly as this, right? So move EAX, move 0 into EAX. That's the equivalent as our sum equals 0. We move ECX, move 10 into ECX, right? Because ECX is our counter. So we have 10 being moved into ECX. Again, you'll notice because we're with the loop command, you're looking for it to be not equal to 0. And so where maybe you and I would normally, at least I normally, if I do a loop, I usually start, I is equal to 0 while I is less than 10, I plus plus. This is a little bit backwards because of the way that that loop instruction works. From there, we have our label for loop start. Then we add to EAX, ECX. So that's like this statement here, sum plus equals I. And then we loop back to loop start, which is our label. So now once we've set up the portion of our for loop, our counter and our sum variable, now we execute the loop. And once we get to the end of our counts, so whenever I is no longer greater than 0, then we're done and execution continues on. The other thing we can do is while loops, and while loops look a little bit different in that we have to look at the structure a little bit different. And you can see here in this example, we have our while label, so that begins or kind of indicates the beginning of our loop. We have to also indicate the end of our loop, and then inside we have a comparison and then a jump. And so what we're doing is, you think about a while loop. We say while some condition is true, then we execute the code inside of that loop. And so that's what we're doing. We're going to enter this loop, and you're going to have code above here and then a comparison, right? So you're going to have code that sets the flags based on a condition. From there, you'll have a conditional jump. You'll say jump if whatever the condition is to end while. So if whatever you're testing is no longer true, then this jump will break the loop. It'll jump to the end while, which then would move execution beyond, right? So then we'd be done with our loop. Otherwise, if it doesn't jump to end while, what do? Well, we go into the body of the loop. We do whatever number of instructions are in this body, and then we have an unconditional jump back to the while loop. There we go back to the code, creates the condition, tests the condition. If it's no longer true, we break the loop. If it is true, execute the body, jump again, right? And so we just continue to do this until the condition is no longer true. So again, it's just a little bit different as far as the structure of this loop when looking at it in assembly. All right, so that's it. That was ifs, whiles, and essentially for loops. So take a look at the code, and again, as usual, let me know if you run into any issues or anything isn't clear. That's all I have for today, and I'll catch up with you guys in the next video. Thanks.